Hey guys, it's John again, and today I'll be sharing with you what are the data types and variables in Java. So we are gonna deep dive today, and I hope you're gonna get really cool informations if you're a junior. So let's go back to the screen and we're gonna have some fun here. If you can see, there is a roadmap again. I'll see the second category called data types and variables. So we're gonna go deep dive and we'll see what are the data types in Java deeply and detailedly. In the left side of my screen I open the data types class and I'll be explaining you everything in data types. So there are two data types in Java. First, the primitive, and the second one is the non-primitive data types. Also, it's called reference because it's referencing a data. They all are objects like strings, arrays, and classes, but we're gonna go that next. So first of all, the primitive data types. Every primitive data type stores simple values in stack, but the reference data types store every data in heap. And the primitive data types, their sizes are already defined into the Java system, and you cannot predefine a value. Like, let me give you an example to explain you better. When you create an array in Java, I'll explain you later, but let me show you. When you create an array in Java, you're gonna predefine a value like new integer 10. This array will use 10 integer value in heap, but you can't predefine a size of a data type in primitive data types like integer, boolean, char, short, or long. Let's go deeper and let me show you the PDF documents that I created. So as you can see, there are some data types here, like the primitive and non-primitive. So in the primitive data types, there are like three categories: numeric, textual, and boolean. Boolean data type is the easiest one, true or false. The textual data types spread it to two categories, byte and char. Bytes, as you can see, they are 8 bits size. It means it's between -128 and -127. I'll show you how to calculate those things also. There is an easy way. You just have to know, and you just have to memorize if you can do the sizes, because every time we create a data, we should choose the correct data type on our program. And also the characters called char, they always store Unicode characters, and their sizes are 16 bits. You can tell it 2 to the 4th power. The other category is numeric primitive types. It means it's also int, short, long, float, and double. They all store numeric data, and it means what I say in numeric data. Integer sizes are always 32 bits, and the short data type, half of the integer data type, it means 16 bits, and the long is double of the integer type, and it is 64 bits. Float is always storing the floating points, and also double too. But there are some rules. Let me go back to the code screen and let me show you what are the size limits and how can you understand the size limits, because you should choose the correct data always compared to your data. So as you can see, there is an integer data variable here, and the data type is int, and it equals to, there's a number here. So if I change this number to one more, you'll see there is a red line under this data. So it says integer number too large, and it means the maximum size of the integer data should be this one. I'll share this data PDF with you guys, and you'll understand better if you can check this out. So there is another data type, as you can see, boolean. Its name is boolean data, and it stores true or false. You can put something here, and this is illegal. This is not correct, and their default value is false. If you can just leave it like this, Java programming language knows this as false value. But if you can change the value is to the true, and Java programming language, of course, is going to understand your data is true. So next is the byte data type, and it's a byte data variable. As you can see, this is the 127. If I change this to 128, it's gonna be said like, hey, this should be int. Actually, it says this should be int, but this number is too large. Let me go to the char. Character data is always equal to the characters 0 to 9, numbers, and some signs like $sign and other things. You can put double character because it's not character. It's now a string. Actually, it's not a string. If I do that, too many characters in character literal. So this is a problem. And this is also 16 bits, but I don't think you're gonna exceed that size. The char data types is always used for the one letter things like the numbers maybe. As I mentioned earlier, the char data is always used by like the characters or letters. Let me just go next. short, the short data is 16-bit data type. If you're storing like small data in that, you should use short. If you change that to 8, the last digit of this number, you'll see this is gonna be int. It's gonna provide me to int data type. But as I said again, the sizes are in the PDF. You'll see the between the numbers. So the next one is long. Long is for the really big numeric data, but you should add the L string literal in the end of the data. If you delete this, you'll see the number is too large for the integer, because the Java programming language accepts this as an integer data type. But you write here long, but you should also show the programming language that it's a long. You should add the L word. But be careful, you can add also lower L letter to here, but it's not really readable. And also long literal ends with lowercase l. This is a long literal. This is just like showing, hey, just let you know this is just a letter, not a number, because so many people are confusing about, hey, it's an L or it's a number of 1, because that's why the Oracle documents are telling us that you should use capital L, more readable code, because what we need to be a senior, we should write more readable code. And the next is float data. Float data is like a floating point, and it's actually showing us the decimal numbers. But if you're writing a float data type, you should add this F string literal in the end of the data. If you delete this, it will accept as the double. You should add and you should declare it as a float data. And as you can see in the double data, you don't have to write any string literal data. But let me tell you something. Float data are always using for the temperatures or like the small data, not for precise values. And also you should never use for the currencies the float data type. And the other side, the double data, you always use for the math functions like sin, max, or some other math functions. That's why you should use double data. And also, here, the big decimal. Let me tell you what's that. If you're storing a currency data, you should use big decimal class from Java, and you should add inside like what is the value of that things. And also, it shows us if you create a new big decimal object, you'll see what can you write in it, and also you can just search it online, the document for that class. Let's go deeper. So also there are some readable code advice at Java. As you can see, integer data with underscore. There is an integer data type and there's a data, but I changed this adding by underscore here, and this will print it the same number like here. So what happens when we add underscore? It helps us, the other developers, easy to read, and is increasing the readability level on the code. And there are some rules. If you are adding an underscore, you can't add before the string literal. Also, you can't add starting of the number. You also can't add after a dot. You can't add here that underscore after the point, the dot sign. There's some rules for the underscore usage, and there are some notes. You can also take that notes from the description below. I'll share every link that I get information from. So there are some using literals on long data types. I already told you what it is, and if you're creating a long data, you should add L letter end of the number. So I also told you before that capital L instead of lower L is better. Okay, we don't use literals on integers, shorts, and bytes. They all get information from integer data types. Okay, shorts, bytes, doesn't matter what you use. And also using literals on double data types, you can make the number like scientific notation. So it means that you can add e string literal here, means 10 to the second power, and they are the same datas. So next, let's see what are the literals rules on characters and string data types. Like if you're creating a string object, actually here you can add in that string like these characters. So this is a characters, this is a character, and this is another character. So here I'm showing the thing, and it's coming from the documents also, Oracle documents. It says sí señor in Spanish, but always use single quotes for character literals and double quotes for string literals, because if you declare a variable called car and if you put only single quotes in it, it's counted as car. that's correct. But if you're putting a double quote in it, it will count as string. It occurs an error and it says, provided you provided me a string. Why are you telling me that it's a car? So enclosing your character string with a double quotes will automatically create a new string object. Just make sure that it's correct. And also Java programming language also supports few special escape sequences for car and string literals. Like this you can just take this out. Like if you just want to put a tab, you can just copy and paste. It will count as a tab. Actually, you should use it like this, because when I paste this, it will add backward slash multiple time. You can use that also like that. Let me just go next. Okay, we are gonna go back to the non-primitive data types, but before that, let me show you some things to my notes. I'll add 3 notes to this PDF file. Float is a single precision data type. Okay, never forget this. And double is double precision data type. And they are asking this in the interview. And it's really a simple thing, but you should know it. Also, let me give you an example from real life. Mostly every junior is forgetting something about choosing correct data type. If you want to check something is true or not, you can use Boolean data types, right? But also you can use 1 and 0. Most beginner developers are creating a data type like here. Let me create an integer value is correct, and this one will be equals 1. Okay, is correct equals 1. And there is another data type here. Let me just write is correct bool and it's true. So if you're using every area in your code base, this one, the integer data type for the checking if it's correct or not, is really bad for memory and it's really bad for your program speed. But if you're making a simple calculator or something, you're able to use that. You can use is correct as an integer data type. But the advice, the thing that have to be like this, you should use Boolean data type for checking correct. Most of the developers, the beginner developers, are making that false thing. Also in the interviews, they're always checking, hey, what are you using? The data types are really important for the future of your software or program. That's a really cool fact about data types. Let's go to the next data type called non-primitive, also called reference data types in Java. So they store all the value in the heap, not in the stack, okay? And store class objects and various type of arrays and also strings come under reference data types. So all reference variables are creating under the constructors of every class. Okay, so if you want to create a string, you're gonna write like a big capital S with the capital S, string S equals some string, okay, some data. And they're always reference variables are created using defined constructors, okay? Their default values are not false or 1 or 0. Their default values are null. As you can see, a reference variable can be used to refer to any object of declared type or any computable type. Like this. I'm taking something from fish class. I'm giving a name called fish, connecting the constructors with new keyword. I'm writing the class again and I'm sending the constructor the name of that fish, like shark, and that's how it works. And this is a non-primitive, also called reference data type. Let's go deeper. Let me start from the strings. So there are, as you can see, this data, as you can see in this PDF, there are three data types in non-primitives. So first one is strings. Strings are immutable and it's really deep in Java. They give extra attention to the strings because strings are immutable. So why? What is immutable? What does it mean? I'll open an article from scalar.com and also I'll add this in the description below. Okay, you can check this out. What is this? So it explains us why string is immutable in Java and what does the string mean. Okay, so immutable means it can't change after defined. You cannot change anything in strings after you define the string. So as you can see, there is a string literal here and it equals the word of hello and it is as 1. Okay, so let me give you a graphical explanation about this. So I'm going to show you an image in this article. As you can see, there is a string pool also in the heap in Java. So there are some objects here, S1, S2, and S3. I also write them there. As you can see, S1 is referencing to the hello. S2 is referencing to hello. S3 is also referencing to hello. And if I change the code, S1 equals to Java. I'm changing the value, okay? Changing the value of S1 and updating the s2 with concat function. I'm just gonna add something end of that word. I'm expecting to be that s2 object will be hello world, right? And then next thing, I'm gonna create a new object and its name is new s3, and it will be equal to s3.concat, and it will add end of the letter scalar, and then I'll just print it out everything. As you can see, the output is here. You can see s1 refers to Java. So what happened? We just referred to hello, and then we just put another equal thing called Java. But I said it's not changeable. If you define the value and you can't change it, right? This is what immutable is. But as you can see, this is referring another value right now. And then the next one, s2, is refers to hello. Okay, it was hello first, but I just updating with the concat operation used here. It should be hello world, but it's not. It didn't change. Third one is it was reference to the same reference like hello, like the s1 object. So s2 refers to hello, and as you can see, there is a concat operation, but it doesn't matter, and you'll see that it doesn't change the value. But the new s3 object that we create newly, it equals to s3.concat, and it's just taking that hello word and adding in the end of the word called scalar. So let me just write everything here, and as you can see, news3 refers to hello scalar, and s3 refers to hello. It doesn't change anything in the s3 object. Even we do this here like the s3.concat, but refers to the new s3 object. But let me show you the graphical explanation. It's really easy to understand. They created really cool image here. So in Java there is a string pool, as I mentioned earlier, and every string literal is storing in that pool, and it's also in generally a heap. So before s1, 2, and 3, they were referenced to the hello world, but we just change the value of s1 to Java. It creates a different string literal in the string pool called Java, and it refers to that. But s2 and s3 is still reference to hello. But you can see s2.concat that work, but unreferenced in pool. As you can see, the hello world is here, but it's unreferenced. It's like empty, it's trash, it's garbage, and it's also memory loss. We shouldn't do that things. And the Java is also warning us, hey, this is ignored. The concat function, the concat method is ignored right now. It means there is a problem here, and there could be a problem for future of your program. So the news3, as you can see, equals to hello scalar, and it's coming from the s3.concat method. And it's creating a new object, it's creating a new string literal in the string pool. And that's why actually. So I just want to point out how string pool is a really cool feature in Java programming language. So we're gonna see that this article is also mentioned that thing, string pool. What is string pool and how is that working? And it's a really cool feature for storing all the strings in one time. And the beautiful side of the string pools, they never create anything one more time. So if you create a hello word, and when you create another object also equals to hello word, you'll see in the image here there is only one string literal here, also called hello. That's a really cool memory allocation thing for the string pool and also Java. And the Java virtual machine, as you can see, performs a sequence of steps while initializing string literals to reduce memory overhead and increase performance efficiency. So you can just check it out what's in the article. I already read everything here, and I'm just gonna share this article also in the description below. It's a really cool article and it helps us lots of things. So I'm just gonna show you the benefits of immutability of string in Java, like a summary of things. As you can see, there's a security benefit. So what happens on the security side, the string immutability? If you have a function like this in the screen, crucial method, and it checks a data from unknown source. You don't know where is that data coming from, right? So it checks name is empty. Okay, if it's empty, there is a security exception, throw it. But if it's correct, you can just go to the next step, like initialize database, and send something to the database. So it can be really problem for the security, right, if someone changed the name. But in Java, the string objects never changeable. that helps. If someone changed in another Java thread after the checking of security exception, that could be a really big problem, and that could be resulted by SQL injections, right? That's the cool side. Also, the synchronization. It can be synchronized on several threads. Okay, Java is not for one thread programs. It can be open for multiple threads. If you create a string object and if you reference it some string literal, you can use that string literal and that object on every thread. You don't have to create another objects for that string literal, okay? And it's a really cool performance feature for the Java actually. And also the hashcode checking. Hashcode checking is a simple thing. We're gonna touch that thing in the next videos, but the hash table, hash maps, and hash set, and so on, all of the hash implementations, they all use the string objects. We're gonna touch that thing. We're gonna be on that thing, go over that thing also, over the hash tables. And when you're there, I'm gonna tell this one more time. You just don't have to worry about it. But in the hash tables, when you're creating a hash code method, you should be sure that hash code never change later, okay? You should be sure that hash code won't be changed later, because that hash code helping the caching mechanism. And as you can see, during the initial hash code call, the hash is calculated and cached, and the same value is returned every time after that. In the end, as a result, while working with the string objects, the performance of collections that use hash implementations will increase. So it helps on the hash code caching, and also the performance, as I mentioned you earlier, it's reducing the heap memory using the string objects, okay? That efficiency, that gives us the efficiency of the program. So that's actually for the strings. Let's go to the arrays if you want. Let me just open the article from Oracle. I also shared this link in the description below. You can check this out. So as you know, arrays are container objects that holds fixed number of a single type. If you want to create an integer array, you must store integer data in it, okay? Because in Java, you should be specific about what you're creating. It helps other developers to read more readable code, right? So in the document screen, there is array length is 10. There are totally 10 index here, and the array length is 10. So here's the array, and let me show you how to declare an arrays. As you can see, you can just write the data type here and add the brackets here, and you're gonna give a name. Name could be anything you want, okay? So you can create a byte array, short, long, blah blah, all the data types, also a string array too. After you create an array, you just have to define a size to that array just using the new keyword. And then the next thing, you can also create an array like this. You don't have to write allocate memory for X integers or something. You can create an array like this, and you can just use the curly brackets and datas in it, okay? When you want to reach this first element, also the 0 index in that array, you just want to write the array name, brackets, and the 0 index. The arrays always starts from the 0 index, okay? Then we can just go next step. You can just write everything here, like I'm just copy and paste the code. But also, as you can see, this is not a readable code, and this is not a good option to write every element on that array. We can use loops for writing what's inside the element. I just want to show you this way too, okay? But we are gonna go the loop things maybe like 2 videos later in this playlist. Let me go there. Is there anything that we should care about? So I think that's everything on the single dimensional arrays. Let's go to the multi-dimensional array and let's finish this video. It's kind of long, I know, but I should mention everything that I learned, because everybody knows the general stuff. You should know the specific stuff in every subject, okay? So let's go to the dimensional arrays. If you want to string multi-dimensional array, you're just gonna use double brackets, okay? We're gonna open a bracket and then open one more time, and you're just gonna give a name, whatever you want, and you can just write here like double curly brackets. So first one is here, the second one is here. When you want to reach an element in multi-dimensional arrays, we're gonna use it maybe a million times in next days, but I'll show you. Let me just show you. You're gonna write it names, and the first index is gonna show us with this one or this one, and the second index is gonna show us in that one or in this one. You can just write it here easily. So actually that's all for the data types and the variables, how to use them, when to use them, and how do you know that string object is reference to something, or how can you reference some string object to another string literal in the heaps. I hope you understand everything. You can just search every document in the description below and you can just check it out, you know, to get better information. There are so many things that can be asked in the interviews, the job interviews. I hope I can give you some ideas about like what they can ask about the arrays, string objects. So it's really easy to understand. So what they're gonna ask about strings. So they can ask what's in the string pool and what happens if some string object doesn't reference any string literals in the heap. So it's really easy to answer, okay, because the garbage collector is gonna come and take that string object because it's not referenced anything. And are the string objects immutable or mutable? And what are the benefits of the string objects? They can ask these kind of things, and it's really cool to know everything beforehand, right? You don't want to learn after the interview what are the string objects, are they immutable or mutable, what are the benefits, or is it good for the performance? Do garbage collectors allows unreferenced string objects or not? They can also ask this kind of thing too. But it's good to know everything beforehand. I hope this video helps you a lot, and I hope you can just imagine something about the data types in Java, because everybody knows integer, long, short, but not everyone knows what are the specific things between them, under of them, backside of them. Thank you for watching that video. If you like this video and you want to show me your support, just like it and subscribe it. That's enough. Thank you so much. See you again in the next video. Goodbye.